Good morning, my dear students. Welcome in power engineering and refrigeration. So, we are in a working of four-stroke diesel engine and we have completed two-stroke, suction stroke and compression stroke. Now, today we are going to switch on working stroke, or we can say expansion stroke. See in a third figure. First figure, suction stroke. Second figure, compression stroke. And third figure, working stroke. Or working stroke is also called as expansion stroke. Working stroke is also called as a power stroke. Working stroke sometimes called as a mechanical stroke, because where we can get brake power to move our machine, move our engine, move our vehicle with load. So that's sometimes that working stroke is also called as mechanical stroke. Now last figure, that is exhaust stroke. So these are the four strokes have with us. On these four processes that diesel engine goes work. So you know very well what happened in suction stroke. See, in suction stroke, amount of fresh atmospheric air comes into our cylinder just by opening inlet valve when our piston traveling from top dead center to bottom dead center. During this period of time, inlet valve must be open and exhaust valve remain closed. So this is what first stroke, suction stroke, have with us by our diesel engine. Now you know that in second stroke, what happened in second stroke. So whatever the charge, so whatever the fresh atmospheric air have with us in our cylinder by before stroke, first stroke, that is the suction stroke. So through with the help of suction stroke, what we got in our compression stroke, yes, fresh atmospheric air through inlet valve. Yes. So whatever the fresh atmospheric air have with us in our second stroke in our cylinder, that fresh atmospheric air, you know very well, it goes compress. And how this air goes compress? Only fresh atmospheric air have with us in suction stroke. Yes. So whatever the fresh atmospheric air have with us in our cylinder in second stroke, that fresh atmospheric air goes compress when piston traveling from bottom dead center to top dead center. Yes. So while our piston traveling from bottom dead center to top dead center, during this period of time, that fresh atmospheric air goes compress, because inlet valve and exhaust valve during this period of time remain closed. Both valves remain closed in the compression stroke while our piston traveling from bottom dead center to top dead center in compression stroke, my dear students. So we saw these two strokes in our last video. Yes, in last lecture. Yes. So those students are absent at the time of that lecture, so please watch it again for revision. So see, my dear students, during compression stroke, both valves remain closed, and whatever the charge have with us by first stroke, that charge or that fresh atmospheric air goes compress by piston traveling from bottom dead center to top dead center. So what we got at the end of that compression stroke, yes, we got heated compressed air. At the end of compression stroke, what we got? Heated compressed air. Yes. For detail, please watch last video. So we got at the end of compression stroke, heated compressed air. Yes, and at this time when piston reaches at the top of the cylinder in second stroke, compression stroke, at the top of cylinder, at that time that fuel injector spreading diesel into the combustion chamber, and as that diesel spreading by fuel injector, the diesel particle going to mix with what? Heated compressed air particles. So that heated compressed air particle having what? Temperature, and temperature responsible to making blast, start to burning that diesel particles, and we'll find propagation flame of our diesel and air particles, and in that combustion chamber burning will be there, and such a burning producing huge temperature, such a huge temperature producing pressure, and such a pressure producing force, and that force we are using in a working stroke. So that force C in a expansion stroke, working stroke, our piston having at the top side. So as that burning is starting, such a burning of charge means air and fuel. Fuel means diesel. Where the diesel is coming? From fuel injector the diesel is coming. The fuel injector spreading the diesel into the compression stroke at the end, where we have a compressed heated particles of air. So that diesel particles, going to mix with what heated compressed particles. So blasting and burning is there of that charge. So such a blasting and burning of the charge gives us pressure, and pressure gives us force. So in an expansion stroke, at the starting of expansion stroke means at the end of compression stroke, it means at the starting of expansion stroke, we have a pressure, we have a huge pressure, we have a huge force, because force converted into pressure converted into force. See, blasting or burning gives us thermal energy gives us temperature gives us pressure, and pressure converted into force. So in a expansion stroke, in a working stroke, in a third figure C, at the end of compression means starting of expansion stroke, have with us force, huge force getting by huge pressure getting by burning getting by blasting getting by heated compressed particles when touching to what? Diesel particles. So this is what sequence, back sequence. So such a huge pressure gives us force at the starting of working stroke, at the starting of expansion stroke, and such a force pushing down our piston from top dead center to bottom dead center, and where we can get the brake power at the crankshaft, and the crankshaft start to rotate forcefully due to that huge force, because that huge force responsible to pushing down that piston from top dead center to bottom dead center. And during this period of time, your inlet wall and exhaust wall again remain closed. So what we're getting at the end of compression working stroke? Brake power. That crank start to rotate very fastly due to huge force. And how that huge force is getting? Huge force is producing due to the pressure, huge pressure. How huge pressure is producing? Yes, that huge pressure is producing due to burning, and where that burning is happen? At the end of compression stroke, that burning is happen. And burning of what? Burning of charge. Charge of what? Charge of air particles, heated air particles, and diesel, fuel. So fuel and air particle, this is called a charge. The heated particle touching to the diesel, because diesel spread by fuel injector into the combustion chamber. And previously what we have in the combustion chamber of our compression stroke, at the end, heated compressed air particles. And such a compressed heated air particles at the end of compression stroke have with us in that combustion chamber, in that heated compressed air particles, diesel spray happen due to fuel injector, because fuel injector is spreading diesel into the what? Combustion chamber. So due to that spraying diesel and heated compressed air particles, blasting and burning is there. One smooth propagation flame will be there, and such a propagation flame producing burning, that charge start to burn at the end of compression stroke, because that diesel particles comes in contact with air particles, heated air particles, compressed air particles. So this action gives us burning, and such a burning producing temperature, and temperature producing pressure, and pressure producing force. And at the starting of our working stroke, expansion stroke, that force pushing down our piston very fastly towards what? Down. Towards what? Bottom dead center of that cylinder. So our piston moving from top dead center to bottom dead center very fastly due to huge force. And during this period of time, when piston traveling from top dead center to bottom dead center, for creating a brake power at the crankshaft, brake power of the crankshaft means the crankshaft start to rotate very fastly and very forcefully. Once that crankshaft start to rotate forcefully, so our load can move easily. according to design, according to the capacity of that pressure, according to the capacity of that engine. So during this period of time, our inlet wall and exhaust wall remain closed. When piston traveling from top dead center to bottom dead center, our inlet wall and exhaust wall remain closed. Then this huge, whatever the force is there, that force success to pushing down what piston from top to bottom, and then we'll getting brake power. So during traveling of our piston from top dead center to bottom dead center, forcefully due to action of force, during this period of time, our inlet wall and exhaust wall remain closed. Now at the end of working stroke, our piston have at the bottom. See in a fourth figure, at the bottom the piston is there. So see, when our piston in a working stroke, when our piston moving from top to bottom due to force, so whatever the burning charge have into that what cylinder, all that burning charge comes or converted into what? Gases, exhaust gases. And so it is necessary to skip out that exhaust gases, step out that exhaust gases, come out that exhaust gases from the cylinder to happen again fresh stroke, first stroke, suction stroke. So whatever the burning particles have into the at the end of expansion stroke, all that burning particles necessary to come out from the cylinder. So that's why exhaust stroke is there. Exhaust stroke means to clean our what? Cylinder. So whatever the burning particles at the end of expansion stroke having, all that burning particles get out, come out, step out from the cylinder when our piston start to move from bottom dead center to top dead center. Now automatically that piston start to move from bottom to top due to the force of expansion stroke. So very fastly that piston traveling from top to bottom in expansion stroke, working stroke, and that with that inertia automatically that piston again moving from bottom dead center to top dead center. And during this period of time in exhaust stroke, whatever the unburned or whatever the burned particles are there, all that unburned and burned particles step out from the what? Cylinder through exhaust wall. During this period of time, exhaust wall remain open and inlet wall must be closed. So this is what exhaust stroke. So exhaust stroke means cleaning stroke. And what it will going to clean? It will going to clean burn particles, completely burn particles. So that exhaust skip out from the what? Exhaust wall while piston traveling from bottom dead center to top dead center in exhaust stroke. So in exhaust stroke, our inlet wall must be closed and exhaust wall remain open. When that exhaust wall open, then that burn gases, burn particles passing through that wall and come into the what? Environment. Goes into what? Environment. So when piston traveling, automatically when piston traveling from bottom dead center to top dead center, all that unburned particles or burn gases come out from the what? Exhaust wall. During this period of time, inlet wall must be open. So see my dear student, this is what working of 4-stroke diesel engine. Suction stroke, compression stroke, working stroke and exhaust stroke. What happens in the suction stroke? When piston traveling from top dead center to bottom dead center, inlet wall must be open, exhaust wall remain closed. During this period of time, when piston traveling from top to bottom, fresh atmospheric air comes into cylinder, that is suction. Now in compression stroke, what happens? Our inlet wall goes closed and exhaust wall also goes closed. So both wall closed in our compression stroke. So whatever the charge have with us, all that charge goes compressed while piston traveling from bottom dead center to top dead center. So charge goes compressed. Due to that compressing, temperature of the air particles goes increase at the end of the compression stroke. So at this time, instantly we'll find amount of diesel or fuel goes sprayed by fuel injector into the combustion chamber, is going to mix with what heated air particles, and where we'll find what burning at the end of compression stroke. So such a burning help to producing pressure. Now such a pressure we are using in a third stroke, that is a working stroke, expansion stroke. So where we'll find huge force, because pressure converted into force, and due to that force our piston fastly moving towards down, that is what brake power, mechanical stroke. And during this period of time, our inlet valve and exhaust valve again remain closed, and that piston moving fastly towards down due to the force. That is what brake power. So in working stroke, we're getting what? Brake power. Now our piston reaches at the bottom side in our working stroke. So in cylinder, we have what? Burn particles. So all that burn particles, all that exhaust must necessary to come out from the cylinder to happen again suction stroke, to continue our order or sequence, to make continuous uniform pressure. So my dear students, so whatever the unburned gases is there into the cylinder, in the last stroke, in the exhaust stroke, we have to step out, we have to clean up. So how it clean up? When piston traveling from BDC to TDC, all that gas come out through exhaust valve into the what? Environment. During this period of time, our inlet valve must be closed. So at the end of exhaust stroke, we find cleaning of our cylinder. Now our first stroke make ready to happen first stroke, suction stroke, because cleaning is there in the last stroke. Again in first stroke, you know very well what happened in suction stroke. Again inlet valve goes open, exhaust valve goes closed to come in what? Fresh atmosphere to continue our order. Thank you very much. If you have doubt, my dear students, please call me. Stay safe, stay home.